All right, assalamu alaikum everyone. Let's begin. Can someone please confirm if you can see my screen? Is my screen visible to everyone?
Yes, sir.
All right. Okay, so today we are going to start the next topic. Yesterday I had some internet issues. Hopefully it will work fine today. We could not start it yesterday, so let's do it today. So the next topic that we're doing is representation of data. All right, so we're done with probability and permutations and combinations. We have done some practice in permutations and combinations already. We'll hopefully spend one more class on that. If you have questions, when we're done with the rest of the topics. Okay, so if you have any questions, we can have another practice session on permutations and combinations towards the end, inshallah. Okay, but that will of course depend on whether you have done some practice yourself or not. Now, today we start this next topic. This is representation of data. This is one of the easier topics in S1. You've done a few concepts of this in O-levels already. So we'll be talking about finding mean, median, mode of data, both for ungrouped data and tabular data, group data. And then we will learn how to represent different data sets in some diagrams, for example, cumulative frequency curve, cumulative frequency graphs, histograms, and then we have a couple of more diagrams that you do not know about from O-levels. There'll be a few new things, but a lot of it is what you've done in O-levels already as well. Okay, so we'll try to be a bit quick about some of the basic concepts first of all. So let's start with ungrouped data first of all. Ungrouped data. Now, what different things are we going to be looking at? First of all, we are going to talk about measures of central tendency. Now, what are they? So remember these quantities: mean, median, and mode. These three things together, they are known as measures of central tendency. All right. In fact, these are three specific measures that we have for central tendency. There are others as well, but these are the three that we have in our syllabus. Okay. Now, what do these measures of central tendency tell us? They basically give us one single value that represents the whole data. All right. So that's what we are looking for from these different measures. We want one value that, all right, so we are looking for one central value that would represent this whole data. All right, so that's why it's called central measures of central tendency. For instance, if I were to have a test in this class, and let's say there were 15 different students, and there was a test, they scored, so each one of you, let's say, had some score out of 50. Now, if somebody was to ask me how the class performed, now I would not really tell marks of every one of you. I would describe the overall performance with a single number. Now, for that, I could use mean of all the scores, or I could use median of all the scores, or I could use mode of all the scores, right? So these are measures that basically are used to represent the whole data, to describe the whole data in one single number. All right, so that's the idea behind that. Now, what we are going to do here is we are going to talk about, first of all, how to calculate these measures for ungrouped data. Now, what exactly is ungrouped data? Ungrouped data is basically data in which we just have some numbers written. Okay, sorry, something happened to it. This is fine. Okay, anyway, let me just copy this thing and take it to a new page because I like lined papers. Okay. Okay, measures of central tendency. So what is ungrouped data, first of all? We are going to learn how to calculate each of these for ungrouped data. For instance, if we have a variable x and it has these values, let's say if I were to write down some random numbers here, 2, 5, 20, 17, 3, 11, 5. I've got some numbers like this. All right. I'm representing these numbers by the variable x. All right. Now, this is ungrouped data. All right. So these are just some values written randomly. So this is raw data basically. It's not categorized in any way. You don't have any frequencies here. It's just some numbers written like this. So this is raw data. This is ungrouped data. For data like this, how do you find, first of all, mean of all of these values? Let's think about that first of all. How do you find mean of this data? So for mean, we have this formula. So if we had to calculate mean of x, this would look like the sigma x over n. Now, what does sigma x mean? Sigma is a mathematical symbol that we use for sum. So this is sum of all x, right? Sum of x. That means sum of all values of x that we have. What about n? N is the number of values that we have in the data. N means the number of values. So if we had to find the mean of this data, we would just add all of these numbers up. So we have 2 plus 5 plus 20 and so on all the way up to 5, and then divide by the total number of values. We've got 4 and 3, 7 values here. So we divide this by 7, and that is going to give us the mean of this data. All right, so just add all of these numbers up, divide by the number of values. There are 7 values, and that gives you the mean. In this case, the mean turns out to be 9. So you just evaluate this and you'll get 9 from this. Now, there's another notation that we will be using for mean that you should be familiar with. So one way to write mean of x is this, mean of x equal to this thing. There's another notation that we will be using, and that is x bar. So if you have x and on top of that x, you have a horizontal line like this, that means mean of x. All right, so mean of x in this case is equal to 9. All right, so this is how you calculate mean for ungrouped data. All right, now let's think about median. How do you find median of data? So the next thing that we have is median of ungrouped data. Now, let me just copy those same numbers here, but for median, you are actually looking for sorted data. It should either be in ascending order or descending order. So in order to be able to find the median, you first need to order the data, sort the data. Median is then defined as the middle value of that data. So middle value of sorted data. If you were to sort the data, put it in ascending order or descending order, then whatever is the middle value, that's the median. All right. Now, first of all, you have to sort this data. So if I were to sort this, how would these numbers look like? I'm going to have 2 first of all. That's the smallest number. Then we have 3. We have 2 5s after that, 5 and 5. And then we have 11, 17, and 20. This is how the sorted data looks like. Now, how do you find median of this data? One way to do this would be that you start canceling numbers from each side. So cancel one number from the right, one from the left, one from the left, one from the right, and so on. The number that you're left with in the middle, that is your median. So this number here, this is the median. So in this case, the median turns out to be 5. All right. So if it's a very small data like this is all that you have to do. Just cancel out the values on the sides and see what number you're left with in the middle. Now, in this case, you had an odd number of values. So, in this case, the number of values n was equal to 7. So we had only one number in the middle. However, if we were to slightly change this data such that we have 2, 3, 5, 5, 11, 17, 20. So we have the same bunch of numbers as before, but now at the end, we also have another number. Let's say we have 22. All right, so now we've got 8 numbers, 8 values. What do we do in this case? You could again start canceling numbers from both sides. So cancel this, this, and so on. Now in this case, you're left with 2 numbers in the middle, right? So you've canceled 3 numbers from each side, and you have 2 numbers left in the middle. What do you do in this case? In this case, you say, just take the average of these 2 numbers that you have in the middle. So that's 5 plus 11 over 2. The average of these numbers is going to give you the median. All right, so that turns out to be 8 in this case. So this is what you can do if you have a very small data like this, just a few values. All right, but if the number of values is slightly bigger, so maybe you have like 30 values, 35 values, then it's going to be slightly more tedious to keep canceling from both sides like this, right? It's going to take time. So for that, we have a formula for median, and that looks like this. For ungrouped data, if we have ungrouped data, median is defined as n plus 1 over 2th value. So the value that comes at this position, that is going to be your median. All right. Now, what does n represent in this case? N is the number of values. N is the number of values. So if you had like 25, 30, 40 values in your data like this, how would you find the median? You would use this formula. All right. Now, let's use this on both of those examples that we did earlier. Let's use it on the first one. In that case, n was equal to 7. If you were to input n equal to 7 in this case, what does that give you? If you were to input n equals 7, that gives you 7 plus 1 over 2. What do we get from this? We get from this 4th value. So whatever is your 4th value now, that's the median. So look at that data, 1, 2, 3, 4. You have 5 at the 4th position. So your median therefore is 5. All right. So this is what happens if the number of values is odd. However, if the number of values is even, like we had in the second case above, n was equal to 8 in the second case. Sorry, the number of values here was 8. And that's an even number of values. What do we do about this? We again use the same formula. But in this case, we end up getting something like this, 8 plus 1 over 2. And that gives us 4.5th value. Now, there's no value that can be classified as 4.5th value, right? We can't have a position that is in decimals. In such cases, when you have 0.5 from this formula, what you do is you take one number smaller than that. So that's the 4th value. One number bigger than that, that's the 5th value. So take the two integers that come on both sides of 4.5, 4 and 5, and now you take average of these two values. So your median is going to be average of 4th and 5th values. This is what you do. Now, what was the 4th value? In the second data, the 4th value was 5 and the 5th value was 11. You take average of them. You take the average and that gives you 5 plus 11. 5 was the 4th value, 11 was the 5th value, 5 plus 11 over 2. And that gives us 8. And 8 is the median that we have in this case. All right, so this is the formula that we can use, n plus 1 over 2. This gives us the position of the median. And then once we have the position of the median, we can write down the median value from the data like this. All right, now next after this, we have mode of data. What about mode? Mode is just the most repeated value. Now you can see in the data, the most repeated value here was 5, right? So 5 is coming here and also here. There are two 5s. So mode therefore is going to be 5 in this case. All right, let me just write that data down here again. Now in this case, you don't need everything to be in order. It could be in random order as well, and that works because you're only looking for the most repeated value. Let me copy the data here. Let's say this was the original data that we had. Now in this case, you just see which number is repeated the most. So in this case, mode therefore is equal to 5. Okay, because we have 5 here and we also have 5 here. There are two values which are both 5. Now in mode, you can also have multiple values actually. So if you had another 20 in the data, then you would say 5 is coming twice and 20 is also coming twice. Both have the highest frequencies in this data. Both have the highest number of repetitions. So you say mode is 5 and 20. Both values could be mode in this case. So you can have multiple modes sometimes as well. Now in your in the questions that you would get, you would mostly have just one, but you should know about this as well, that it is possible to have multiple modes sometimes if you have the highest repetitions coming for two separate numbers, or it could be more than two as well. So you can have more than one mode in that case. All right, so that is also possible. All right, so that's about mode. This is how we calculate these three measures of central tendency from ungrouped data. All right. Now, this is not it. This is not enough to describe a data set fully. You also need something else along with measures of central tendency to describe the data better. Now, to understand that, let's take these two examples. Let's say I have a data that looks like this. I have, let's say, 1, and then 8, 20, then I have, let's say, 33, and let's say 37. Does that work? Let's check. 19, 12, and 29. and 12, that is 29. This is 13 and 17. Okay, so instead of 1 here, let's actually use 2, and that will make it easier. Okay, so let's say we got this data. And now let me write down another data set. That looks like this. I have values like 18, 19, 20, 21, 22. I've got these values in the data. All right. Now, if I were to find the mean of this data, the first data set, you'll find that the mean turns out to be 20 in this case. Add all of these values up, the mean turns out to be 20. Find the median of this data, median is also 20. So mean and median of this data are both 20. Let's look at the second data set. What's the mean of this data? Mean of this data is also 20. And the median of this data is also 20. So we've got two separate data sets, and in both of them, the mean and median, they are both the same. Now, does that mean these are exactly the same data set? Because remember, what did we say about mean and median? They are used to describe a data. So if somebody was to tell you there are two data sets, they have the same mean and the same median. Now, are they the same? If you look at these two data sets, the first one has a lot more variation in the values as compared to the second one, right? The first one has a lot more variation as compared to the second one. All right. Now, let's say you were hired at a company. So let's say these are two companies. This is company A, this is company B. And let's say somebody was to hire you. Somebody was to offer you positions at both of these companies. So you have an option to choose A or B. And what happens is they assign you some salary randomly from these numbers. So you know that there are 5 employees at each company right now. In the first company, they're getting these salaries. Let's say these are salaries per, let's say per year, per month. Okay, let's say these are monthly salaries, and let's convert this to some other unit. Let's say 2000 would be too little. Okay, so in any case, let's say we say that these are yearly salaries for somebody working in Pakistan, let's say yearly salaries in dollars, and we're saying thousands of dollars. Okay, so at company A, there's one person who's getting a salary of $2,000 a year, another person who's getting a salary of $8,000 a year, another person who's getting a salary of $20,000 a year, and so on until you have somebody getting $37,000 a year. At the second company, these are the salaries that they're getting. Okay. Now, if somebody was to tell you that you have an option to go at one of these two companies, and there are 5 employees working at each of these two companies, and these are the salaries that they're taking. Now, they have the same mean, they have the same median, and you were told that you would be assigned one of these salaries randomly, and one of these salaries randomly. Now, is it going to be the same if you were to choose company A or company B? In company A, there is much higher risk because you could end up getting 2,000 as well. Although there is a possibility that you could end up with 37,000 as well, but there's more risk. And with that more risk, there comes more reward as well. But if you were to choose company B, in this, it's a lot more safer. So you are basically certain to get at least 18,000, even though the maximum is not that much, but still the minimum is 18,000. All right. So this is the worst scenario that could happen to you. So basically, the point is, mean and median, these alone are not enough to describe data. There's another thing that is called that is called variation, that is also important. So if we look at the first data, this is much more varied as compared to the second data. This is less varied. So in order to quantify this variation, we have some other measures which we call measures of measures of dispersion. So to quantify this variation, we have some more measures now, and these are called measures of dispersion. And what they do is they tell you about the variation in the data. They tell you how dispersed the data points are. All right. Now, there are 4 of them which you need to know about. First of all, you have range. Then you have interquartile range. Then you have standard deviation. And there's another measure that's closely related to standard deviation, and that's called variance. So you need to know about these 4 measures of dispersion. What do these measures tell you about? They tell you how much variation you have in the data. Okay. They tell you how much variation there is in the data. So they quantify the variation. So you can say these are numbers that quantifies, that gives a number to variation in the data. All right. So basically, we just looked at these 2 data sets earlier, and we said the first data is much more varied as compared to the second data. But how do we measure that variation? How do we say how much more variation is there in the first data as compared to the second data? How do we compare the 2? For this, we have these measures called measures of central tendency, measures of dispersion, which quantify, which give some numerical value to that variation. All right. Now let's talk about each one of these one by one. Achha, before we do that, can somebody please confirm if my screen is clear for everyone? Is there any lag, or it's fine for everyone?
Sir, it's fine. There's no lag.
There's no lag? Okay, so on my other device, I'm getting some lag. Okay, that's good. All right, now let's talk about each of these measures one by one. First of all, we have range. Now, range is pretty straightforward. You've done this in O-levels as well. Range is just defined as maximum value minus the minimum value. So whatever data that you have, range is the maximum value minus the minimum value. That's how range is defined. All right. Now for this data, for instance, range would be 37 minus 2. And that turns out to be 35. And range of the second data is 22 minus 18, which is 4. So this is one way to quantify this range. For the first data, the range is 35. And for the second data, the range is just 4. So there's more variation in the first data as compared to the second data. All right. So that's the first measure that we have. Now, this is not used a lot in practice. The reason for that is it is affected a lot by extreme values. So for example, in the second data, I've had one more value that was 200. Now the range would change to 188, or in fact 82 in this case, just because of this one value. So range is easily affected by outliers or extreme values, because just maximum minus minimum. So even if there was just one value that was way different from the rest of the data, the range would be affected. Now, even though there's hardly any variation in the rest of the values, just by this single value, the range is affected. All right. So it's not used that much in practice because of this reason, but you should know about this. Still, there's a better measure than range that's called interquartile range. Now, how is this calculated? Interquartile range. Now, there's a specific method for this that we use here for ungrouped data, and you should make sure that you use it as it is, as I'm going to be explaining here. And do not try to use formulas here, okay? They sometimes end up giving you incorrect values. So make sure that you follow this process exactly as I'm explaining here. This is really important. You might have done it differently in O levels, but here you have to do it exactly the way I'm going to tell you about now. All right. Let's take an example. Remember what interquartile range used to be? Interquartile range was upper quartile minus the lower quartile. But how do you find those upper quartile and lower quartile? That is what we're going to talk about now. Let's say we've got one data set that looks like this: 2, 3, 5, 12, or let's say 5, 11, 17, 20, 25, 30, 31, 40, and 52. I've got this data set. All right. Now, if I were to find the lower quartile and upper quartile of this data, this is how the process is going to work for this. What we do is we first find the median of the data. That's the first thing we have to do. We find the median of the data. Now, how many values do we have? We've got 5 and then 5, 11 values in total. So median is going to be 11 plus 1/2. That's sixth value. Sixth value in the data is here. This is the median of this data. All right, this is the median of the data. Now, once you've found the median, this median divides your data into two equal parts. You've got one part on the left side of it and another part on the right side of it. And now what you do is you find the median of each of these two parts separately. Find the median of the left part. What's the median? There are 5 values. The median is going to be right in the middle, and that is this value. The median of the left part here, this is what your lower quartile is. This is the lower quartile. And we often denote it by this LQ, lower quartile. All right. And then if you look at the right side of the median, you have 5 values on this side as well. What's the median of those 5 values? The median of these 5 values is 31. So median of the right side, that is going to be your upper quartile in this case. Okay, so you first have to find the median. Once you have found the median, that median divides your data into two equal parts. Median of each of those parts is going to give you lower quartile and upper quartile separately. Okay. Now, if you have the upper quartile and lower quartile here, you can find the interquartile range. So interquartile range, IQR, what is that equal to? That equals upper quartile minus the lower quartile. You just input values here. The upper quartile is 31 in this case, minus the lower quartile, that is 5. The interquartile range turns out to be 26 in this case. All right. Now, let's take another example. So sometimes what happens is median is not a number in the data, but it's calculated by taking average of the middle two values, right? Like you saw in one of the earlier examples. Let's see what happens in that case. So let's say we've got this data now, the same data, but I'm going to change this slightly such that we have one more value in this data. So let's add 60 to it, let's say. How many values do we have in the data now? We had 11 earlier. Now we've got 12 values. So remember how the process works. If you have to find the interquartile range, how do you start? You first have to find the median. Now, what's the median of this data? 12 values, 12 plus 1 over 2, that gives you 6.5th value. That means you have to take average of the 6th value and the 7th value. What's the 6th value? The 6th value is 20, the 7th value is 25. Median is going to be the average of these two numbers. So this is where the median is going to be average of 20 and 25, which is 22.5. That is what your median is. Now, once you have found the median is not one of the numbers in the data now. Median is somewhere in the middle here. Median is the midpoint of 20 and 25. So the two halves that you're going to consider now are going to be this from 2 to 20 and from 25 to 60. These are the two halves that you're going to consider. All right. So you are going to include 20 in the first half and 25 in the second half. And now you find medians of these two halves. Now, if you look at the left side has 11 and 5 in the middle. So what's the median of these two values? It's 8. That is your lower quartile. Right? That's 5 plus 11 over 2. That's 8. Look at the right side. The median of this part is going to be average of these two values. Take average of these two values. 40 plus 31, that's 71 divided by 2. That gives you 35.5. That is your upper quartile. And from this, you can now find the interquartile range. The interquartile range is upper quartile minus the lower quartile. Upper quartile is 35.5. You subtract from that the lower quartile, which is 8. And the interquartile range, therefore, turns out to be 27.5. This is how we find interquartile range for ungrouped data. Okay. Now, you might see formulas being used in books or wherever. Do not use those formulas. They will work for most of the cases. They will give you the same answers in most cases. However, there are some cases in which the formulas do not give the correct answer. And if you look at the marking scheme, they will give you the answer that you get using this method. All right. So this is the convention that Cambridge uses for ungrouped data. These are the other method is also correct. Using formulas here is also correct in general, but Cambridge uses this convention that for ungrouped data, this is the method that you have to use. If you don't use this method, and use the formulas instead for ungrouped data, you will end up getting incorrect answers sometimes. Okay. So those some instances are enough for you to avoid using formulas, because it could be in your exam that the answer that you get from that formula is not what they give in the marking scheme, because they use this method for their answers in the marking scheme. All right. So you have to be using this method in Cambridge A-levels exams for ungrouped data. Keep that in mind. Okay. So this is exactly the process that you're going to follow for that. All right. Now we do have some formulas as well, but we use them for group data, not for ungrouped data. All right. So since we're talking about this, let me just tell you about those formulas. What does lower quartile mean? Lower quartile, for instance, stands for the 25th percentile. 25th percentile. So you know about those formulas from O levels. If you had to find the lower quartile, what you would do is you would multiply the number of values by 25, divide by 100, or in other words, n over 4. The value that comes at this position, n over 4th position, that is your lower quartile, right? That's the formula that you used to use earlier. Similarly, if you had to find median, What does median mean? Median means 50th percentile, right? That is 50 over 100 times n, times the number of values. That could be simplified to n over 2. So the value that you are getting at this position, that is your median. And similarly, if we had upper quartile, for upper quartile, you have 75th percentile. That's the definition of upper quartile. It's the 75th percentile. How do you calculate 75th percentile? 75 over 100 times n, or 3n over 4. The value that you get at this position, that is going to be your upper quartile. All right. Now, you don't use these formulas for ungrouped data. These are actually formulas that are used for grouped or data that is for group data, or the data that is represented in a cumulative frequency curve. So when are you going to be using these formulas? You use these formulas if the data is in grouped form. So in the frequency table form, for instance, or when it is represented using a cumulative frequency curve. So if you had to find the median, lower quartile, and upper quartile from that graph, in that case as well, you use these formulas, but you don't use these formulas for ungrouped data. For ungrouped data, this is the process that you have to follow that we did earlier. Okay, you don't use these formulas for ungrouped data. So these are not used for ungrouped data. All right, keep that in mind. So these are some measures of dispersion that we have. Now, the next thing that we have is standard deviation. Now, that's really important. Let's talk about that before we end. That's the last thing that we're going to be doing today. Standard deviation. And also variance. Variance is very simple once you understand standard deviation. So the next thing that we have is standard deviation. Now, what about standard deviation? Now, standard deviation is another measure that we use for finding dispersion in data, for finding variation in data. All right, let's think about this. Let's say you've got some data points. You have a data that has values like this. So you've got some x values, x is the variable, and you have some values of x. Let's say they are 13, 5, 21, 10, 16, 25. You've got values like this. All right. Now, let's say you have the mean of this data. So how do you find mean of the data? Mean of the data is sigma x, sum of all values divided by the number of values. There are 6 values in total here. You add all of them up and divide by 6. All right. So 13 plus 5, you do that on a calculator, add all of them up and divide by 6 and see what that gives you. This should give you 15 as the mean, right? So 18, 21, that's 39, 49, and then 65 and 25, that's 90, 90 over 6. That gives you 15. So your mean here is 15. Now, what exactly is standard deviation? Standard deviation basically tries to measure how much distance do the values have from the mean on average. How far are the values on average from the mean value? Okay. So mean is 15. how far is 13 from that? How far is 5 from that? How far is 21 from that? What's the average distance from the mean? That's what standard deviation tries to measure. All right, average distance from the mean. Now let's try and think about this. We've got one variable that is x, and it has these values, 13, 5, and so on. I've written these here. Let me just copy them here again. So I've just copied those values here. These are the values of x that we have. Now, what we're looking for is we're looking for the distance of these values from the mean. So in mathematical form, that would look like this: x minus x bar. All right, so we subtract the mean from each value. Right, so 13 minus the mean, 5 minus the mean, 15 minus 21 minus the mean, and so on. What's the first value? If x was 13, 13 minus 15, that gives you minus 2. 5 minus 15, that gives you minus 10. 21 minus 15, that is 6. 10 minus 15 is minus 5. 16 minus 15 is 1. And 25 minus 15 is 10. These are the differences, the distances of these values from the mean. And remember what I said? Standard deviation is roughly something that measures average distance from mean. All right. Now we have the distances from the mean. If we could try and find the average of these distances, if you were to try and do that, add all of these values up: minus 2, minus 10, plus 6, minus 5, minus 1, plus 10, and then divide all of that by 6, you will realize the sum of all of these numbers actually turns out to be 0. The sum of all of these numbers turns out to be 0. And that will always be the case. Why? Because mean is actually calculated in such a way that the differences of the values which are smaller than 15 and the values which are larger than 15, they are equal. So the sum of all the negative values here and the sum of all the positive values here, that basically cancels each other out every single time whenever you take differences from the mean. So you'll always get 0 as the result if we were to just use these differences like this. All right. So this doesn't work like this because we have some negative differences, we have some positive differences. They cancel each other out and the average will always turn out to be 0. So we have a way of handling this thing, and that looks like this. So basically, we are just interested in the distance from the mean. So we're not interested in whether that difference is below the mean. So whether that number, for example, 13 in this case, is below the mean or above the mean. We're only interested in how far that number is from the mean. Now, it could be towards the left of 15 or towards the right of 15. We don't care about that. So the difference could be negative or positive. We don't really care about that. We just care about the fact that it is away from the mean and we want to quantify that distance that it is away from the mean. All right. So we have to somehow get rid of these minus signs from x minus x bar. Now, one idea that we use for this is that to make these numbers, make these differences positive, we square this whole thing. So we say, let's square x minus x bar, because remember, whenever we square something, the negative signs become positive. So when we do that, x minus x bar whole square, this gives the first value turns out to be 4. The next value turns out to be 100. Then 6 squared is 36. Then you have 25. Then you have 1. Then you have 100 again. All right. And now what you do is you take average of these values. Okay, there's a Zan going on here. I'll take a break of 1 minute and then we resume after that. All right, so this is what we were doing. So what we did to get rid of these negative signs was that we squared these values. All right, so we said, let's square these values and that would get rid of the negative signs. And then rather than taking average of these differences, what we do is we take average of these squares. So what we do is we just add all of these numbers up, 4 plus 100 plus 36 and so on, up to the last number, which is 100 again. We add all these numbers up and we divide this by 6 to take the average of these squared differences. All right. And then once we're done with all of this, since we have squared these values, since we have squared all of these values, and the unit would have now changed, right? Because this number is going to turn out to be something pretty big. So in this case, if I were to calculate this is equal to 44.33. Now that's pretty big. The numbers are much smaller. We are saying on average, this is what the difference looks like. But this is because the differences were actually squared. So they have become much bigger than what they actually were. So what we do at the end is we take square root of this whole thing to get back to the original unit. So for example, if the unit of x was centimeters, unit of these squared differences would be centimeters square. So we want to go back to the original unit to get those average differences, right? So what we do at the end is we take the square root of this whole thing. So the standard deviation formula after all of this looks something like this. If we have a variable x in ungrouped form, Standard deviation is defined like this. You say it's sigma sum of all of these values, sum of x minus x bar whole square. So you find these squared differences and then you add all of them up like this. So that's sigma x minus x bar whole square, squared differences, and then sum of all of them, whole divided by n. So whole divided by n, this is n, we divide by 6, take the average, and then we take square root. This is the standard deviation formula that we have. Sigma x minus x bar whole square. We find the differences, square them, and then add all of them up, and then divide by the number of values, which was 6 in this case, and take square root of that. So this gives, in this particular example, this gives us 44.33, and then square root of that, which results in 6.66 in this case. All right. So this is how the standard deviation calculation is done. Now, this is one formula that we have for standard deviation. There's another formula that you'll also see written in the markings in the formula sheet. That formula looks like this. Sigma x square over n minus x bar whole square. And this formula is actually derived from this first formula. We use some summation rules here to basically get from this form to this form. But these both formulas are given in the formula sheet. And you would realize that using this second formula is actually much more efficient in most situations because the calculations become a lot simpler in this case if you were to use the second formula. So now both of these formulas are going to be given in the formula sheet. You will find yourself using the second one a lot more because this is going to be quicker. How exactly is this going to be quicker? Let me show that to you. So these are the values of x that we have. These are the values of x. What did we have to do for the previous formula? For the previous formula, we had to find all of these differences. And then we had to square all of them. And then we had to take average of those square differences and take square root at the end. If you were to use the second formula, what does this look like? It has sigma x square. You don't need to calculate differences in this case. All you have to do is just find the squares directly. So find 13 square, that is going to be 169. Then find 5 square, that's 25. 21 square is 441. 10 square is 100. 16 squared is 256. 25 squared is 625. And now you just add all of these values up. So that would be sigma x square, right? Sum of all x squares. So add all of these numbers up. This turns out to be 1616 for me. All right. And now for finding the standard deviation, all you have to do is use sigma x square, right? So that's 1616, divide by n. N is the number of values, which is 6 in this case, minus the mean. Mean was 15, right? Mean for this data was 15. We found that earlier. Square that mean, and then take square root of this whole thing using the second formula. And this is much quicker than the previous one. And this gives you the same result as well, which is 6.66. So you will find yourself using the second formula a lot more. Why? Because this is much easier to use. It's much quicker. You will only be using the first formula when sometimes they give you this form directly. So they might tell you sigma x minus x bar whole square is equal to this. Now find the standard deviation. Or they might give you the standard deviation. This might be given, and they might give you the value of n and they might ask you to find sigma x minus x bar whole square. In that case as well, you would be using the first formula. But in general, if you were just supposed to find standard deviation from raw data like this, the second formula is going to be much quicker. Both of these are going to be given on the formula sheet. You can just use them from the formula sheet directly. Now, you might think there could be another way of making these differences positive rather than squaring them, right? So for example, you've done one function and that used to square, that used to make negative values positive, that you've done in paper 3. And that is the modulus function. So you might think of using the modulus function here instead. So you have the differences x minus x bar. Now, since they could turn out to be negative in this case, in order to make them positive, you might think of making them positive like this, taking modulus instead of squaring. That is also possible. And then you can add all of them up and then divide by n. That could also give you the average difference from the mean. But this is not what standard deviation, this is not how standard deviation is defined. This is actually another measure, which is called mean absolute deviation. And it's often written like this, MAD, mean absolute deviation. This is another measure. This is not in your syllabus. This is not in your syllabus for O levels, for A levels. You might study this later in university, but for standard deviation, this is what you do. You square and then take square root at the end, rather than using modulus function. If you remember, modulus function was actually quite hard to deal with. So there are actually certain reasons for not using this. Basically, you can't find derivatives of such functions, or you can't integrate such functions. And in order to do some more advanced calculation on this particular measure, you need derivatives and integrals, which is not possible for absolute functions, for the modulus function. So that's why it's not used as commonly in practice. You will find yourself using standard deviation a lot more. So this is part of your syllabus. Mean absolute deviation, which you might think about doing when you are finding the differences, that you could just put the modulus sign there. This is actually another measure, but that's not part of your syllabus. Standard deviation is calculated like this. All right. These are the two formulas that we have for that. Then we have the last measure, that's variance. Variance is pretty straightforward. Variance is actually just standard deviation squared. Standard deviation squared. This is what variance is. So basically, in these formulas, if you were to get rid of these square roots, that is variance. All right. So if you did not use the square root, the expression inside, that would be variance of the data. All right. Now we have an interpretation for standard deviation. Standard deviation is roughly the average distance of the values from the mean. Variance, on the other hand, does not really have any interpretation alone. Variance is mostly used to compare data sets. If you have two data sets, you could compare them using standard deviations. You could say one data has this standard deviation, another has this standard deviation. The one that has more standard deviation is more varied. Variance, even though it does not have any interpretation on its own, for comparison, this works pretty similar to standard deviation, because if one data has more standard deviation, it would also have more variance. All right. So we often use variance to compare data sets as well. It alone does not have interpretation for one particular data, but if you had multiple data sets and you had to compare them together with each other, variance serves the same purpose as standard deviation. In that case, if the variance is more, you could say the data is more varied. Variance also actually makes smaller differences more significant. That's one practical implication of this. Sometimes you want small differences to be highlighted. Variance does that for you because it squares those differences. So even if the difference is small, it gets highlighted more. If you were to compare two data sets, if there were more differences between them, variance would highlight those differences more because it's squared. All right, but that's something again that you would find uh, later in university. For now, all you need to know about is how this variance is calculated. So we know how to calculate standard deviation. Variance is just square of that. All right. I hope that makes sense. If you have any questions, you can let me know. But that was all that we wanted to do today. It was a longer class today because we missed yesterday's class. I wanted to cover a number of things. I hope that makes sense. If you have any questions, let me know. Otherwise, that's it. And see you again tomorrow. Any questions, anyone? No? All right. That's it then. Allah Hafiz.